Okay, today we'll continue the yesterday's. Okay, where we left. Okay, we have seen the parallel programming in the software. That's nothing but the parallel programming in the parallel computing in the programming side. That is to be with the shared memories. Okay, shared memories. Okay, we'll continue the shared memory with the same with the one more concept. That's the thread safety. Thread safety. Okay, thread safety. Okay, in many cases. Okay, Amresh, सीधा कूद सीधा कूद रहे In many cases, the parallel programs can call the what functions, okay, which are developed by the which are developed for the serial programming, okay, serial programming. But these functions can also be used in the parallel programming also. But the thing is that if I use the serial programming, okay, serial programming, serial softwares like some functions, such a functions to the parallel programming, what will the some problems will face, okay. Those are we can notice the notable problems are there. One is what here the exceptions in the if I make the use of the static local variables, okay, static local variables. If I use that is to be static where local variables means what it is to be available to the only one program, only one program that is to be having the running on the single core, okay, single core. But sometimes if I use the static local variables, it is to be shared one, okay, it is to be shared one that is to be available even the even the core of this next program also, okay, next program also. Sometimes we knew this, okay. Sometimes static variables also defined with the private also with the keyword private private and the ಮಾಡಿದ್ರು that is to be transfer. If I call the functions, okay, if I define, okay, okay, let me serial. Okay, some programs are there which are related to serial programs. Here I have the I will be using the some functions, okay, some functions, okay. These functions can also be used in the parallel programming, parallel programming. But this is to be leads to some problems, okay, then some exception will occur, okay. This type of functions will be called sometimes to the even the parallel programming also, okay. In the parallel programming, while we will define in the some functions, whatever the functions I defined in the serial programming, that is to be having the variables as the static variables, okay, static variables, okay. Static variables means what these to be available to the particular function only, function only. But okay, in the parallel programming I have the so many threads, okay. I have the so many threads as thread 1, thread 0, thread 1, okay. If I call the this function serial function, serial program function into my parallel programming, okay, that is to be used in the thread 0, okay. Even the same thread 0 is to be transferred to the same function to the thread 1 also, okay, thread 1 also, okay. This leads to the problem because the already static variables are defined in the serial program as the private, even that is to be available to the next thread also, okay. This is the main drawback here, okay. In order to overcome such exceptions, okay, we will be defining the some variables here the called as the static char, okay, static char. Static char is the static char is the one of the variable which if we define the such a variables, okay, in the first thread that is to not available to the next thread also. This is not a be called this is the we can say it's the static, okay. If I define the any variable with the static char or static, okay, that is to be called to the another thread also. This is to be available sometimes. But here the static if I define the some variables with the static char also, that is not available to the next thread also. It means here the if I define the some variables with the functions, that is to be not available to the next thread also. But the thing is that some functions will have the some variables which are defined with the private even available to the next thread also. This is the an exception, okay. To overcome such an problem, okay, exception, we'll have the thread safety. We have the thread safety. That thread safety concept will be defined with the static char, okay, static char, okay. Static char means what here the you have the I have the one method, okay. Str strtok, okay, strtok, stroke, okay. If I call a, there are threads are there. There are two threads are here, thread 1, thread 0, thread 1, okay. If I call, okay, if I call the function as the stroke, okay, stroke is the one of the function, okay, stroke is the one of the function which will the divide the character given string into the two halves, as the one string will be defined into two halves as the string part of the okay. If I have the some string, okay, okay, upper college, okay, this is to be defined into, if I call the function as the strtok means a okay, a stroke function, then the definitely this string will be divided into two halves, as the first will be what here the upper, another is what college, okay. That's nothing but here the we are defining, okay, we are dividing the such a string into the two halves here, two halves, one is and this one second, okay, with the help of the stroke method, stroke function, strok, str or tok, stroke, okay, stroke, okay. This is to be here the, if I call, if I start the calling the functions as the thread 0 and thread 1, first we will call the thread 0 first call, next is what thread 1, okay. If I call the thread 1, the thread 1 will do the some functions, okay, more faster than the thread 0, more faster than thread 0, but here the whatever the thread 1 is there, that is to be divided into some character is there, some string is there, that is to be divided into two halves, this to be saved where to the thread 0, because the thread 0 is functioning slower, okay, thread 0 is functioning slower, whatever I defined, whatever I divided the function, okay, that string, that is to be returned to the thread 0, but here the whatever the thread 0 is having the string, that is not available to the next level of threads, but thread 1's string, whatever divided thread 1, that is to be available to the thread 0, means here the thread 0 string is overwritten here, okay. Thread 1 string is continued to the each and every threads, because of the thread 1 is working faster, thread 1 is working faster with the function as the strtok. If the two threads are running, first one is first called the thread 0, next this is also called, but thread 1 is works faster compared to the thread 0. Thread 1 will be dividing the given string into two halves. This result is to be stored back to where in the thread 0. Thread 0 data is to be overwritten here. Thread 0 data is to be overwritten, okay, but the thread 0 is having, earlier it was having the some string here, that string is overwritten because of the thread 1 values, thread 1 string values, because of the I called to the strok function here, strok function, okay. This is to be unexpected, because the we have to get the both, okay, as the same as this, the call the thread step tok for the thread 1, even thread 0, that is to be, it should not overwritten, okay, that should not overwritten, but this is overwriting the things here, the whatever the thread 1 is having the values, that is to be sent to the thread 0, this thread 0 value is overwriting here, okay. This is the main drawback here, okay, this is the main drawback here, okay. So that in order to overcome this one, we'll give the thread safety to the thread safety method to be implemented with the calling the function as the thread safe method, okay, thread safe method, okay. Programmer need to worry, okay, this has to be very be aware of the things, such as things, while writing the explicit programs, while writing the such a programs, okay. Programmer has to have the good experience while writing the programs, which method he has to call. If he called the such a strtok method, it will be overwriting the earlier thread also. So in order to overcome such a problems, we can call the programmer should have the a good experience, hands-on experience while calling the functions in his programming. Okay, such a problems can be avoided by calling the thread safety method. Thread safety method. This one we call as the thread safety method. Thread safety method is available in the multi-threaded, okay, multi-threaded, okay, multi-threaded programming, okay, multi-threaded programming, okay. This used to be used for the block of the data can be blocked here, and even that block of data can also be used while calling the method, okay. That's the subroutine programs, okay, subroutine programs. As you know, this one subroutine programs are the nothing but the program, okay. This is the main program, this is the some small piece of program. This main program is running wherever you have necessary to have the small piece of code that is to be called with the some address here, that is to be once again it is to be come back to the after execution of this small piece of code, then control comes back to the main program whenever wherever it is necessity for the such a program, then we can call with the particular address of that program. This means what we can avoid the redundancy in the program, and also we can write the small piece of code also, size of the code also reduced. But here if I use the strtok such a methods in the C programming with the thread 0, thread 1, it will the overwriting the data. Yeah, we are losing our data. Okay, this can be overcome this with the help of the thread safe method. Thread safe method. Okay, please take the notes. Small take notes. Okay, thread safety. Write the thread safety. In many cases, in many cases, in many cases, in many cases, okay, in the distributed memory programs, the cores are the okay, the cores are directly accessed by the their own. Okay, as we know that distributed memory programs, okay, distributed memory cores and all, they will have the their own private memory to that particular core. Okay, similarly, here also we have the in the distributed memory programs also we have the their own private memories. Because of this, we can also define the some variables which are to be particular core only. Those variables can call the private variables. Private variables, okay. Those variables can also be called as the private variables, okay. There are several APIs available in the distributed memory programs. One is called the simplest is what here, the best is what here, the message passing API. Another two are the what here, the one-sided communication. Another is the what here, the one more is there, one-sided communication. Another one is the partition global address space language. Okay, these two are the APIs. Okay, there are three APIs. First among that one is what here, the first one is what a message passing API. Message passing APIs are also sometimes called as the interfaces. Okay, interfaces. Okay, message passing API is nothing but the MPI. Okay, MPI. This is the method. Okay, this is the interface which will be used for the writing the some programs which are related to distributed memory programs. Okay, distributed memory programs. Okay, because of this, while using the distributed memory programs, will use the message passing APIs. Passing APIs uses the some interfaces. Those we call as the message passing interfaces. Message passing interfaces. Okay, as we know that there are APIs. Okay, okay, there are APIs. Okay, APIs nothing but the API and the application programming interfaces. Okay, these interfaces are used for the for writing the for calling the some okay, this is like a blueprints for the particular method or particular program which will provide the interface to the writing of the programs, which will be we call the different variables, even parameters to the number of variables, and also even call the number of variables, okay, arguments also. But here the APIs will provide the some blueprint. Okay, how many interfaces are available? There are three APIs are available in the distributed memory programs. That's nothing but the one is what here, the message message passing API. Another one is what, one-sided. Another one is what, partitioned partition global edition global address space language. Okay, partition global address space language. Okay, space language, these are the three main APIs available in the distributed memory programs. Okay, among that one will be first one is very important for the even lab also, even programming side also, but here the one side communication, another is the what partition the global address space language. This will be not useful, but here the first one is the message passing API is the very important. Okay, a number of groups are languages are available for the parallel programming. Okay, but here the message passing programming is interface. Okay, shh. Hey. Okay, these are the some variables we'll be using. Okay, message passing variables. Okay, we want the will provide the some address to the particular space. Various threads are available, and also if you want, we'll have the some library related to the compiler also. Okay, we'll give the some programs related to these programs are written in the API. That's nothing but the interfaces. Message passing API interfaces. Okay, message passing interfaces. Okay, we'll consider the first one is the message passing interfaces. Message passing interfaces will provide the send or receive methods. Okay, two methods are available in the message passing APIs. Okay, in this we have the two methods. One is what send or and also receive. Okay, send or receive are the two methods. Okay, send or receive are the two methods. Send method will be for the if the any thread zero is sending the some values. Okay, some any values that is to be received where in the thread one, that is to be until the thread method. Okay, send method will be active until the receive method will be getting the that for particular function of that for particular order. Okay, that the receive method will start. Send method will be active until the receive method starts. Okay, until the receive method starts. Okay, we can also we have the so many the processes. Okay, even we already knew this one shared method programming side. We always talk always on the what here the threads threads threads, but here in the distributed memory program side we'll always talk on the process programs process. Any program that is to be considered as the one process that can have the so many number of tasks. Okay, so many number of tasks. Okay, that we call as the thread safety. Okay, but here the in this programming side distributed memory programs always will use the process. You should remember. Okay, if you have the typically if you have the number of processes which will be having the some ranks. There we have seen the ranks for the thread 0, thread 1, thread 2. Similarly, even we'll also have the processes also have the some ranks as the rank 0, rank 1, rank 2. Like this, we'll have the this processes can give the ranks as the 0, 1, 2, 3 up to the P. Here the P is nothing but what here the process. Okay, P is nothing but the processes. Okay, this P is nothing but here the processes. Okay, one should you should have to remember here the sorry 0 to 0 to P minus of 1. Okay, 0 to P minus of if there are n number of P number of processes are there, then the rank should be here the what here the 0 to P minus of 1, where P is the process name that can also have the P processes having the rank of last process having the rank as the P minus of 1. First process will have the rank as the rank 0, rank 1, rank 2, rank 3. Like this, will have the different ranks for the different processes. For the last processes, will have the rank as the P minus of 1, where P is the calls the processes. We calls the processes. For example, okay, in shared memory system, we will always talk on the what here the their threads. In the distributed memory systems, memory programs will always some programs will have the those program parts will call the process. You should remember there will be using the thread 0, thread 1, thread 2 like this. But here the in the distributed memory programs, we'll always use the processors 0, processors 1, processors 2, like this. Okay, we can also have the give the rank as the 0 to p minus of number of ranks. Okay, let us to consider the two processors here. One is what? Processors 0 and processors 1. Okay, these two processes will communicate with one another. If you want to communicate with one another with the help of the, we will be having the some methods here. Okay, some methods, send method is there, another one is what here, the receive method is there. A send method is there, another one is the receive method. Okay, send method will send the from process 1 to the process 0. Okay, process 0 will receive the sending value from the process 1 to the process 0. Okay, this can be understood by the while writing the some small piece of code here. Let me write that one. Okay, care message message 100. That is the having the message of that one will be having the care of 100 the numbers. And also my rank for the my rank is what here, the okay, just to copy the figure or that program. Okay, in the program you can see the methods. Okay, one is what here, the send method, another one is receive method. Okay, send method is there, another one is the receive method is there. Send method is there, another one is the receive method. Okay, just to copy that program. character message, okay, 100, okay, we are defining the how many number of characters, that's to be 100. The my rank method is there. Another one is what here, the okay, get rank, okay, get rank is there, okay, it will give the ranks, okay, okay, that is to be what here, the my rank, that my rank will be what here, the one, okay, one is for the particular method which is to be sending the values, okay, some messages to the what here, the next processes, okay, the that is to be received, the processes 0 will receive the another method, that is the send receive method, that is to be ranked with what here, the 0, my rank is 0, okay, get rank which will give the two ranks here, the 0, another one is what here, the 1, for the rank of 1 which will give okay, process 1 will send the some values, okay, some values, okay, that is to be received in the where, in the process 0, okay, just to copy that. Copied here, that program, okay, character message 100, okay, my rank is equals to get rank as the, okay, if my rank is equals to 1, then the there are two methods. One is what, sprint, okay, messages greetings from the process 1, another send a message to the message character equals to as of 100, else my rank equals to 0, receive method is there, that will the receive the whatever the send from the process 1, process 1, ಏನು ಏನ್ರಿ ಯಾಕ ಕಾಣಿಸಲಾಗಿದೆ ಈಗ, ಕಾಣಿಸಲಾಗ್ಯದ ಎಸ್ ಪ್ರಿಂಟ್ creating the some messages, okay, okay, creates the a message, okay, so sprint will creates what a message, okay, it will create in the message. ಇಲ್ಲ ಇಲ್ಲ ಕರೆಕ್ಟ್ ಅದ, ನೀವು ಪ್ರಿಂಟ್ ಎಫ್ ನೋಡಿ, ನಾನು ಪ್ರಿಂಟ್ ಎಫ್ ನೋಡಿ, ನಾನು ಪ್ರಿಂಟ್ ಎಫ್ ನೋಡಿನಿ, ಬಟ್ ಇನ್ ದ ದೇರ್ ದ parallel programming with the C program, that's we call the S print will create the some message, creates the message. This method will not create printing any value, okay, this will creates the some creates the message, okay, that created message used to be sent to where in the process 0, process 0 ಮ್ಯಾಲಿಂದ process 1 ಕೆಳಗಿಂದ process 0 ಇದೆ. Okay, get track function, write it. Okay, take the some notes. For the internal examination, I will be asking this question. Okay, message passing interface. Okay, this is the MPI is the important for your integrated lab also. Okay, Open MP and MPI. These two are the interfaces I will be using the in the lab. Okay, integrated lab we have no. There I will be using the in programming side. These two interfaces I will be calling every time while writing the program. Okay, that's what I am teaching. This one is a very slowly, okay. In the coming module, that is to be second module, is very easy. I will complete that within a 3 to 4 classes, okay. That is very easy. That small top module, ಮತ್ತೆ ಅವ ಮೇಲೆ 3 4 ಎಲ್ಲ ದೊಡ್ಡ ದೊಡ್ಡ ಅದಾವ, ಕಳಿಸಿದ್ದೀನಲ್ಲ, I already sent to the group, that is some PDF files are there. ಹಾಂ ರೀ, ಇಂಟರ್ ಕ್ವಶನ್ಸ್ ಕೊಡ್ತೀನಿ, 20 ಕ್ವಶನ್ಸ್ ಕೊಡ್ತೀನಿ. ಕೇಳ್ರಿ, 20 ಕ್ವಶನ್ಸ್ ಕೊಡ್ತೀನಿ ನಾನು, ಕೇಳಿ ಕೇಳಿ, 20 ಕ್ವಶನ್ಸ್ ಕೊಡ್ತೀನಿ, ಕೊಡಲ್ಲ ಅಂತಲ್ಲ, ಆದ್ರೆ ನಾನು 12 ಕರೆಕ್ಟಾಗಿ 12 ಕೊಟ್ಟಿರ್ತೀನಿ, ನಿಮ್ಗೆ ಹೇಳ್ತೀನಿ ಇಂಪಾರ್ಟೆಂಟ್ ಯಾವ ಅಂತ. 12ದಾಗ 10 ಕೇಳ್ತೀನಿ, ಆಯ್ತಾ. 20 questions to assignment for your examinations, but here the I'll be giving for your for the internal tests. I'll give the 12 questions. Okay, among the 12 questions, I'll be asking the 10 questions for your internal examinations. Yes, sir. Okay, almost all question paper leak out. Hey. Okay, message passing in. Okay, next point. Okay, Sumkuda. Okay, there are two methods here. The one is what here the get rank method. Get rank method will give the some ranks to the particular processes. Okay, as the process 0 will have the rank 0 and the process 1 will have the another rank that we call as the rank 1. Okay, I'll give the some ಏನು ಗೊತ್ತಾಗಲ್ಲ ಕ್ಲಾಸ್ ಹೆಂಗೆ ಇರ್ಬೇಕಂತ ಗೊತ್ತಾಗಲ್ಲ ಹಿಂಗ ಹಾ ಇಲ್ಲ ನಾನು ಶೋ ಆಫ್ ಮಾಡಕತ್ತೀನಿ ಇಲ್ಲಿ ಕೂತ್ಕೊಂಡು ಕೇಳ್ತಾರ ಕೇಳ್ರಿ ಇಲ್ಲ ಎದ್ದವ್ರು ಅಂತ ಹೇಳಿನಿ ನಿಮ್ಗೆ ರಿಕ್ವೆಸ್ಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ ನಾ ಮತ್ತೆ ಫೈನಲ್ ಆಗಿ ಹೇಳ್ತೀನಿ ನಿಮ್ಮ ಇಷ್ಟ ಎದ್ದು ಸೌಂಡ್ ಮಾಡಿದ್ರೆ ಎದ್ದು ಹೊರ್ಗೋಬೇಕು ಈಗ ಹೇಳ್ತೀನಿ ನಾ ಇಲ್ಲ ಸುಮ್ ಕೂಡ್ಬೇಕು ಕ್ಲಾಸ್ನಾಗ ತಿಳಿತು ಕೇಳು ತಿಳಿಲಿಲ್ಲ ಅಂದ್ರೆ ಕೇಳು ಓಕೆ ಸರ್ ನಂಗೆ ತಿಳಿದಿಲ್ಲ ಇನ್ನೊಂದ್ಸಲ ನನ್ನ ಲೆವೆಲಿಗೆ ನಾನು ಐ ವಿಲ್ ಟ್ರೈ ಟು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮೈ ಲೆವೆಲ್ ಬಟ್ ಥಿಂಗ್ ಇಸ್ ದಟ್ ಯು ಆರ್ ಮೇಕಿಂಗ್ ಸಚ್ ಅ ನಾಯ್ಸ್ ಐ ಡೋಂಟ್ ಲೈಕ್ ಓಕೆ ರಿಕ್ವೆಸ್ಟಿಂಗ್ ಯು if you repeat it like this I will send you out particular names with particular names okay okay get rank okay get rank is the one of the function which will be returns the calling to the process rank as the, giving the names as the rank as the process 0 will have the rank as the rank 0 and also process 1 will have the another rank that is called as the rank 1 like this we'll have the different ranks to the particular processes as we already seen and also process 1 will create the some message okay as we have seen the process 1 here this will create the some message okay yes print is the one of the method that will create the some message okay this message to be where you have to send where in the process 0 second method okay process yes print is the one of the method which will create the some messages okay these messages will be sent to the processes one with the help of what a send method okay receive method will be active only when the send method is receives to the receive method okay that's nothing but with the my rank is the ranks given to the processes okay process 1 is having the rank 1 my rank 1 and processes 0 will have the my rank 0 okay these two are the methods okay we'll be using for getting the ranks okay and also some variables are defined here which are to be received from the messages the number of elements available for the storing the messages and also rank of the processes sending to the one process to the another processor which will be based on it while creating the get method will give the some ranks to the particular processes okay several points can be noted here first one is what here the this one is completely we call you can call the SPMD, whatever we have seen in this program, this is like a SPMD. SPMD is nothing but the single program, multiple data. Okay, whatever we are having the single program is there, we are sending the multiple data means what with the help of the what are the some processes. There we are sending the data in the form of what with the threads, but here we are sending the data in the form of processes here. This we call the single program message okay multiple processors okay single we can say it's what here the single program with the multiple data e1 we can also say this one is the SPMD e1 you can also say it's as a single program multiple processors single program with the multiple processor okay this one we call the SPMD this is the one of the notable method in the notable thing here and the second notable the point is here that these are the variable messages whatever you are referring these are to be referred to be as the different processors okay one process will have the one message is another variable have the another message here it's nothing but the we are sending we are notice we can notice here the variable message is there this variable message can be vary from one processor to the another processors okay another processor and also finally we can also assume that the std out is nothing but the std out is the one of the method which will be used to get the some APIs related to the most of the cases assuming that this type of right to and also write back process will get the from the std out. The std out is nothing but the standard output message, means that here the we are writing the something to the display here. Okay, display here. There are several possibilities of such a behavior. We can send and receive the messages from one processors to the another processors with the help of what here the some more functions are there. Okay, these functions to be what here the send and receive methods are can also be modified with the few more adding the values and variables, and even we can also send the some parameters to the particular methods also. Send and receive methods can also be increment. Some can have the different methods here. So the, we have the so two have the we can have the two methods here. The one is what here the collective communications. Collective communications are nothing but we can have the collective. Okay, while adding the results from the process 1 and also process 0, we can collectively we can also get the collective communication here. And also we can also reduction in the computed value here the with the single result. Whatever we are getting the result from the computed, those process 0 process 1 will be reduced to what here the single value, that is we call as the reduction in the result. Okay, these two are the methods which will be used for in the distributed memory programming. Okay, and also we have the some special functions related to the communication of the message processes. These special functions we can call what here the interfaces here. Okay, message passing interfaces are the some of the which are important methods which will be used for the in the multiple programming parallel programming side. Multiple processes with the parallel programming. MPS are the one of the good special functions which are used in the distributed memory programming side. Okay, MPS are nothing but the message passing interfaces. Message passing interfaces. Okay, message passing interfaces can have also have the powerful and the powerful and very versatile in nature. Okay, these are the because the virtually the programmers are usually access the some math some space from the powerful computers that used to be used everywhere. Nowadays we are using the some powerful spaces which will be our cloud like this because of using the some virtual programming. Okay, these programming will be give the such a programs can also be built or written with the help of the distributed memory programming side. Distributed memory programs are nothing but the parallel programming with the distributed programs. These will be using the different methods which the are nothing but we call as the in message passing interfaces. Different methods with different special functions we can say it's as what are the message passing interfaces. Message passing interfaces are the useful for while writing the such a distributed memory programming side. Okay, also okay, one more is there. Message passing interfaces will have the low level. Every time we need to we need to split the some serial programs with the number of collective parts. Okay, this will be time consuming. We are doing the some low level of design work here. That's what we can say. It's the MPS are called as sometimes called as the level of programming. Low level programming with low level of programming will be written with what here the message passing interfaces. Okay, message passing interfaces. And also we have the parallelism in the serial to the parallel program. We can also be done with the some rewriting of the majority of the part of the program. This can be writing of the majority of this part of the program for every time. This can be avoided with while using the some interfaces. If I call the message passing interface, there I can also write overwrite the some values whatever I need. There I can also send the some values, and even I can also send the some variables in the particular interfaces. Okay, message passing interfaces also sometimes called as what here the assembly language programming for the parallel programming. Okay, message passing programming is there. No, message passing programming with the help of the interfaces sometimes called as the assembly language programming in the parallel programming side. Assembly language programming in the parallel programming that is to be done with the help of the MPI, in case message passing interfaces. Okay, you should remember. Okay, assembly language programming can be achieved in the parallel programming with the help of what kind of interfaces? Those that is to be parallel, that is to be message passing interfaces only. Message passing interfaces only. Okay, you should remember. Okay, two more APIs are there. One is what's the one-sided communication. Another one is what here the okay, yes, partitioned. Okay, next class I will discuss partition global edition space languages. Okay, Okay, one-sided communication. One-sided communication will have the two processes. One is called the one process must call the send method. Another process must call the receive method. One-sided communication has nothing but here the one method has to one process has to send the method as the send method. Another method has to call the receive method. Send method will be active until the receive method is going to be active. Until the receive method will receive the send method, then only receive method will be active. This is also sometimes called as the one-sided communication because of the two processes are there. Explicitly, we are giving the values. Okay, until the we are getting the one-sided communications are nothing but the if you want to access the remote access, remote memory, we will be using the some single processes calls the update and also even you can also get the even we can also get the update of the remote processes. Okay, if you want to communicate with the communication with the remote memory access, a single process calls the function which we call as the updates. Okay, updates method, if we call the single method, that is nothing but the updates method, the processes one will be updates until the processes next process will get calls the another update method. Okay, two times at a time will not get the update method here, only one time update method will be called to the particular processes here. And also we have the different type of single, we can also say it's what a single process one-sided communication because of the we will be using only one processes. Okay, instead of using the multiple processes, we'll be using the only one processes here. You are the Furthermore, if you significantly reduce the cost of the communication because of the one-sided communication, we'll be using the only one core is here, and also we will be decreasing the overhead. Okay, because of the overhead is nothing but the one-sided communication will get the because of the one-side communication will give the overhead. Overhead is nothing but here the send or receive methods will be faster compared to the other functions. And also here the if the processes 0 is copying the variable from the processes 1, if it's copying the value from the processes 0 is copying the some value and processes 1 will be receiving the some other value. Processes 0 will be copying. Okay, any of it is copying, we can say it's what here the overwork is to be done because of the copying function will be completed, will continue until the process of the values to be copied to the completely to the process 1. Okay, I'll complete. Okay, I'll complete this one. Okay, okay, there is a flag of I within a within a 1 minute. Okay, I'll complete this model. Okay, and also I'll be using calling the flag. Okay, flag raise. Okay, flag will be raised only when the particular process is to updates its method. Okay, updates means what, it's if any memory is to be updated for the particular processes, each and every processes will have its own private memory, that is to be a private memory has to be updated with the call of the function, what function, update call method, update call function, update call method or update call function. Okay, these are the methods to be used. Okay, and also we have the partition global address space language. Partition address global techniques will be used for the thousands of processes here. These processes will be divided into different groups. Okay, with the different tasks. So in order to get this particular task to be first, that is to be having the some ranks. Okay, while giving the some ranks to the elements. Okay, if you want to add, okay, if you want to copy the contents of the array. Okay, there are two arrays are there, one is what x array, another one is what y array. Okay, each and every array. Okay, x array will have the some elements, y array also having the some other elements. Okay, if you want to communication between the one array to another array with the help of what is the send and receive methods which are to be used. Okay, and also will have the first element has to be copied. Okay, some x elements has to be copied to where in the y value with the help of the x of array equals to plus or plus equal to y of array elements. Okay, partition global address space methods are which will be used for the allocation of the shared memory systems. Okay, which will be provide the shared memory systems. Okay, PGAS is nothing but the partition global address space. Okay, provides the some of the mechanisms, okay, which are to be related to shared memory programs, but in the distributed memory programs, okay, we'll be using the just discussed whatever we discussed here, the private variables will be used. Okay, okay, nowadays several projects are based working on the working on the SPGS only. Okay, several, okay, nowadays parallel programmings, whatever we have seen in the electric bikes, okay, electric bikes are electric cars, there will be using this kind of parallel programming. Okay, you should remember why they have introduced the parallel programming subject means what nowadays e-bikes, e-vehicles, wherever will be using these vehicles. Okay, tra- transport industry, they are using the e-bikes means what they will be using the parallel programming. Okay, okay, there will be using the SPGS, which is that partition PAGS means partition global address space. This will complete what here the module 1. Okay, so that tomorrow onwards I'll come start with the module 2 here. There module 2 I'll take the around 3 to 4 classes because it's a small topic is there. Okay, anyway I'll be completing the before the first internal, I'll complete the 2 modules. Okay. Thank you. Thank you.